Good morning, students. Our today's topic in the subject of chemistry is empirical formula and molecular formula. So it's a technical topic. There will be some techniques used in the lecture. So concentrate yourself. This is one of the very important topic in the formula or in the formulae and stoichiometry topic. So the question from this topic always come in the paper. So concentrate yourself now. We are going to start. First, the empirical formula. The empirical formula shows the simplest whole number ratio of the different types of the atoms present in a compound. For example, here are four compounds given, and the requirement is write the empirical formula for. So, first formula is of hydrazine. So, formula is N2H4. So, actually, the simplest whole number ratio is called empirical formula. If you can see here, the maximum number that can divide the both numbers is 2, because in 2 is coming and 4 is also coming. So 2 ones are 2 and 2 twos are 4. It means NH2. So this is the simplest whole number ratio. So it means some maths, the concept of some maths will be applied in the question. Look at the next one. So the maximum table in which these numbers are coming are 2. So 2 4s are 8 and 2 9s are 18. So formula will be C4H9. So this is the simplest whole number ratio. So this is the empirical formula. Look at the third, that is benzene, C6H6. So the maximum table in which these numbers are coming is 6. So 6 ones are 6, 6 ones are 6. So CH is the empirical formula of this compound. The last one is ammonia, NH3. So if you see, no table is there except one in which the all numbers are coming. So this formula will be remain same. So this is the empirical formula of this compound. Look now, the important steps are now coming. The following steps are used in the determination of the empirical formula. First step will be identify the various elements present in the compound. Second step will be find the mass in grams of each element present. You may use the periodic table as well. This third step will be determine the number of the moles of each element present. Answer must be of at least up to 2 decimal places in accuracy. So these are the conditions which you have to follow. The answer should be up to 2 decimal places. The next step will be divide each value of the number of the moles by the smallest of the values. Round off the answer to get whole number. When a mole ratio is within 0.05 plus minus of a whole number, it is safe to round off. Next step will be, if the number of numbers obtained are not whole numbers, multiply each number by an integer so that the results are in whole numbers. And the final step will be write the empirical formula using these numbers as subscripts of the elements in the formula. So these are the steps which you have to learn first, because now these steps are going to be applied in solving the questions. So now concentrate, because when we will solve some questions, these concepts, these steps will be more clear in your mind. Look now, first example. A white powder is analyzed and found to contain 43.64 grams of phosphorus and 56.36 grams of oxygen by mass. What is the empirical formula of the compound? It means phosphorus and oxygen are present there. So write P and O. Now, because their masses are given, mass of the phosphorus is given 43.64. Look now, mass 43.64 and of oxygen is 56.36. So these are the masses. Next step will be use the periodic table to find the relative atomic masses of phosphorus and oxygen. So relative atomic mass you may see from the periodic table is 31 and of oxygen is 16. Next step will be, we will find the moles by dividing the mass over relative atomic mass. So 43.64 over 31 will be equal to 1.41, and 56.36 over 16 will be equal to 3.42. So these are the number of the moles. Next step will be divide the both numbers with the smallest one. So these are two numbers now. Definitely this is the smallest. So divide this number by this number and this number by 1.41. So look now, 1.41 over 1.41 is equal to 1, and this number by 1.41 will be equal to 2.5. So at this step, you may see the numbers are not in whole numbers. So if the numbers are not in whole numbers, so multiply the numbers with a number so that the numbers may come into whole number. So because 2.5 can become a whole number by multiplying it with 2. So multiply the both numbers with 2. So 1 2s are 2 and 1 2.5s are, sorry, 2.5 2s are 5. So here are the numbers now. And final step will be, because these are now whole numbers, so represent these numbers as the subscript of the elements. So P2O5. Look now, P2O5 is the empirical formula of the compound. So these are the steps. First you have to remember, first you have to learn these steps, and these are the application of these steps. Look now, another question is here. Things will be more clear. Vitamin C contains 40.92% carbon, 4.58% hydrogen, and 54.50% oxygen by mass. So what is the empirical formula of the vitamin C? So mass per 100 grams of the compound, 40.92 carbon, 4.58 hydrogen, and 54.50 oxygen. So these are three elements present in the compound. Next step will be, we will use the periodic table to write the relative atomic masses of the elements. So relative atomic mass of carbon is 12, of hydrogen is 1, and oxygen is 16. Next step will be, we will find the number of the moles of each atom. So number of the moles is 40.92 over 12 will be equal to 3.41. 4.58 over 1 will be equal to 4.58, and 54.50 over 16 will be 3.41. So here are the three numbers now. Now we will select the smallest one. So the smallest one is 3.41. So we will divide the three numbers by 3.41. So look now, divide by the smallest number. So 3.41 over 3.41 will be equal to 1. 4.58 over 3.41 will be equal to 1.34, and 3.41 over 3.41 will be equal to 1. At this step, we are seeing that the numbers are not in whole numbers. So we will multiply the numbers by a number to get the answers as a whole number. So look now, this is the decimal number, 1.33. So that will be multiplied, that this number will be multiplied by 3. So if this is going to be multiplied with 3, so we have to multiply the other two numbers with 3 as well. So look now, 1 into 3 is equal to 3. 1 into 1.34 into 3 is 4, and 1 into 3 is 3. So at this step, you can see all the numbers now in whole numbers. So the final step will be, make these numbers the subscript of these atoms. So C3, H4, O3. So this is the empirical formula. And other question is here, when 1.55 grams of the phosphorus is completely combusted, 3.55 grams of an oxide of the phosphorus is produced. Okay, this is the compound and this was the element which was going to be burnt. Deduce the empirical formula of this oxide of the phosphorus. It means phosphorus will be burnt in the presence of the oxygen. So it means there are two elements, that is phosphorus and oxygen. If the mass of the phosphorus which is going to be burnt is 1.55 and the total mass of the compound is 3.55, so if we subtract the mass of the phosphorus from the full compound, we will get the mass of the oxygen. So these are the masses now. From here, the second step will be applied. Now we will use the periodic table to find the relative atomic masses of these atoms. Of phosphorus is 31 and of oxygen is 16. Next step will be we will find the number of the moles. So 1.55 over 31 will be equal to 0.05 and 2 over 16 will be equal to 0.125. At this step, we will select the smaller number or the smallest number. So that is 0.05. So we will divide the both numbers by this number. So 0.05 over 0.05 will be equal to 1 and 0.125 over 0.05 will be equal to 2.5. At this step, we are seeing that the numbers are not in whole numbers. So we will multiply the numbers with a number to make them whole numbers. So this 2.5 can be 5 by multiplying by 2. So if this number is going to be multiplied with 2, so we have to multiply 1 with 2 as well. So 1 into 2 is 2 and 2.5 into 2 is 5. So these are whole numbers now. And the final step of the procedure is make these numbers the subscript of these atoms. So P2O5 is the empirical formula. Okay, next topic which is going to be start is the molecular formula. The molecular formula shows the actual number of the each type of the atoms present in a compound. The molecular formula is a simple integral multiple of the empirical formula. If the empirical formula of a compound is CH2O, then the molecular formula is CH2ON, where n is an integer. So it is a simple integral multiple. So the procedure of finding the value of n is molecular mass over empirical formula mass. So this is the method, this is the procedure of finding the value of n. Molecular mass over empirical formula mass. The following steps are used in determination of the molecular formula of a compound. So these are the steps. First, obtain the empirical formula of the compound, which you have learned. The second step will be calculate the empirical formula mass. Next step will be calculate the ratio molecular mass over empirical formula mass, that will be n. And the very final step will be multiply the subscript in the empirical formula by it to obtain the molecular formula. So these will be the steps, and now we are going to solve a question that will make our concepts more clear, how molecular formula can be obtained. So a very simple question at first. An organic compound has an empirical formula is CHO2. So this is very simple question. Empirical formula is already given. Mass spectrometer determination shows that the compound has molecular mass of 90.1. So molecular mass is given. What is the molecular formula of this compound? So this is empirical formula and molecular mass is given. So first we will find the empirical formula mass of the compound, that is CH2O. So C is 12, H is 1 and O is 16. So 2 atoms are there. So 2 into 16. So this is the empirical formula mass. Molecular mass is 90.1. So N will be equal to molecular mass over empirical formula mass. So 90 over 45, 2. So now this is the number which will be multiplied with the subscript of the empirical formula. So look now, CHO2 bracket, and this 2 will be placed outside, and in next step that 2 will be multiplied inside. So C2H2O4. So this is the molecular formula. Look now another question. An anesthetic compound is found to contain the elements carbon, hydrogen and oxygen. The percentage by mass of these elements are given below. 1 mole of the compound has a mass of 74 grams. What is the molecular formula of the compound? Empirical formula of the compound is this. So again, empirical formula is given and molar mass is also given. So the simple method is, first we will find the empirical formula mass of the compound, that is C is 12. So 4 atoms are there. So 4 into 12, H is 1, 10 atoms are there, 10 into 1, O is 16. So solve it on the calculator. This is the molar mass, molecular mass of the compound. Okay, this is not the molecular mass, this is actually empirical formula mass. Okay, molecular mass is also 74. So it means molecular mass is 74 and molecular mass is also 74. So now N will be found by a molecular mass over empirical formula mass. That will give us answer 1. So molecular formula will be C4. So this is the empirical formula. So this will be written inside the bracket, and the answer 1, that is N, will be written outside. So 1 will be multiplied inside. So same formula will be there of the molecular formula as well. Okay, another question is here. A chemical substance in a photographic fixer solution contains sodium, sulfur and oxygen. So sodium, sulfur and oxygen. Chemical analysis of this sample shows that this sample contains 0.98 of sodium. Here is the mass. 1.37 grams of sulfur, this one, and 1.02 grams of oxygen. So here, so these are the masses given. Now we will, okay, requirement is determine the empirical formula. The steps will be same. First we will use the periodic table to find the relative atomic masses of sodium, sulfur and oxygen. Now we will find the number of the moles by dividing the mass over relative atomic mass. So these are the moles. Now we will choose the smallest number and divide the all numbers by that number. So here are the numbers. But look, these numbers are not all whole numbers. So we will multiply by 2 to convert them into whole numbers. So these are multiplied by 2. So here is 3, 2 and 2. So now make these numbers the subscript of the atom. So Na2, S2, O3 is the empirical formula. So this is the question, students, the last one, which actually come in paper number 2 of chemistry, in which some things are given. The first requirement will be find the empirical formula, and after that, in second part, you have to find the molecular formula. So look at this question. This type of questions come in the paper number 2 of chemistry. Look now, 0.43 grams of the organic compound. So this is the organic compound whose mass is given, which contains only carbon, hydrogen and oxygen, was burnt in excess oxygen. The combustion produced 1.10 grams of the carbon dioxide and 0.45 grams of the water. This compound has a molar mass of about 85. So molar mass is given. Calculate the empirical formula. Second part is molecular formula. So look now, actually these are the elements which are present, carbon, hydrogen and oxygen. So actually we have to find the masses of carbon, hydrogen and oxygen first. So look now, this is the total mass of the organic compound. So and the products which are produced are carbon dioxide and water. So we have to find the masses from the carbon dioxide and water. So these are the things. So look now, to find the mass of the carbon in the compound, mass of the carbon in the organic compound is mass of the carbon in carbon dioxide. So carbon dioxide is C is 12, O is 16, 2 atoms are there. So 2 into 16, so this is the relative molecular mass of CO2. The number of the moles of the CO2 will be equal to mass over molar mass. So this is the mass 1.10 over molar mass is 44. So these are the number of the moles of the carbon dioxide which are produced in the process. So now we will find the mass of the percentage mass of the carbon in carbon dioxide. So look now, 1 mole of the carbon dioxide contains 1 mole of the carbon. Hence, number of the moles of the carbon is 0.025. So this is the thing. Relative mass of the carbon is 12. Now we are going to find the mass of carbon in CO2. So moles multiplied by molar mass. because 1 mole is there. Okay, sorry, 0.025 moles are there, and molar mass is 12. So 0.30 is the mass of the carbon in CO2. Okay, next thing which we are going to find the mass of the hydrogen in the resultant compounds. So look now, to find the mass of the H in the compound, mass of the hydrogen in the organic compound is equal to mass over height of hydrogen in water. First, we will find the relative molecular mass of H2O. H is 1, 2 atoms are there, 2 into 1 plus O is 16. So this is the relative molecular mass of the H2O. Molar mass of the H2O is 18 grams per mole. Number of the moles of the H2O. So the mass of the H2O is, look at the question, 0.45 grams of the water. So this is the mass which is produced in the because mass in the question was given for 0.45, so mass over molar mass, so 0.45 over 18. So these are the number of the moles of H2O which are produced, and in H2O molecule there are 2 moles of the H. So 2 multiplied by this number, so these are the number of the moles of H. So this is the number now. Okay, therefore the mass in the H in H2O is moles multiplied by molar mass. So this is the mass of the H2O, because it is given that there are only 3 elements, H, C and O. So if we have find the H and C, so add them and subtract from the mass of the compound, that is this one. So 0.43 minus, here is the mass of the carbon and here is the mass of the hydrogen. So when these 2 masses will be subtracted from the full compound, we will get the mass of the oxygen. So this is the tough process after which we have come here, and now this is the stage from onward. The method, the procedure of finding the empirical formula will be started. So look now, carbon, hydrogen and oxygen. Carbon's mass is 0.30, hydrogen mass is 0.05 and oxygen mass is 0.08. Now we will use the periodic table to find the relative atomic masses. Carbon is having 12, O1 and H1 and O16. Next step will be find the number of the moles. So 0.30 over 12 will 0.025, 0.05 over 1, 0.05, 0.08 over 16, 0.005. At this step, we will choose the smallest number. So the smallest number is 0.005. So divide all the numbers by 0.005. So here will be 5, here will be 10, and here will be 1. So these are whole numbers. So now we are going to make these numbers the subscript of these elements. So C5H10O1 will be the empirical formula. Look now. So first part is done. Can you see the difficulty in this kind of questions? So these kind of questions students come in the paper number 2 chemistry. So B part is still left, and B part is find the molecular formula. So first we will find the empirical formula mass. So C12, so 12 into 5 because 5 atoms are there. H is 1, so 1 into 10, and O is 16. So this is the molecular formula, empirical formula mass. Okay, look now, in the question, the molecular mass is given, that is 85. So almost we are done. So look now, molecular mass is this one. Now we will find the N by dividing molecular mass over empirical formula mass. Molecular mass is 85, empirical formula mass is 86. So dividing them, we will get the answer 1. So we will multiply this number with the empirical formula. So put the formula into the bracket and n outside the bracket like this. Now because n is 1, so 1 will be multiplied inside, so no change will be there. So molecular formula will be the same as that of the empirical formula. So this was the topic, students, one of the technical topic, particularly the last question. So read the full lecture again, make your concepts clear, understand them, make your notes. Thank you so much.